This video is going to cover how to simplify expressions with exponents using the quotient rule. In other words, we're going to talk today about what we do when we have exponents in our fractions. All right, let's go ahead and begin. So in order to simplify any expression with a fraction, I need to take into account that these things are being multiplied, and I secondly need to take into account what repeated variables I have on top and on bottom. So as I look at these two expressions, these two halves of my fraction, I notice that only the top part of the fraction has a b, but both the top and the bottom have a c and a d. Remember, when I am simplifying something, if I am dividing by itself, I can cancel two things out. I kind of like to think of fractions as a civil war. If I have the same factor on top and on bottom, they cancel each other out. They go to war and they cancel each other out. So as I look at this expression, C cancels out C and D cancels out D. Now there's nothing to cancel out B, so as I rewrite my fraction, B remains on the top of my fraction. Now as I look at 32 and 40, remember this is a fraction. I'm looking for common factors. I like to use a calculator to simplify the fraction. So I type in 32 fraction, but that simplifies to 4/5. So when I write my fraction, I'm going to make sure that 4 goes on the top with the b and 5 goes in the denominator. And this would be my simplified expression. So let's try that again. Just make sure you got the hang of that. So again, I'm going to look at the variables and look for any common factors on top and on bottom. X is going to cancel out x, and y is going to cancel out a y. As I rewrite my fraction, w remains on top, and 30 over 36, 30 over 36 is 5 over 6. Now, can that be simplified without using a calculator? You bet. Remember, when I simplify fractions, I look for common factors. So 30 splits into 5 times 6. 36 divides into 6 times 6. And the same rules with the x's, I can divide those out. So 5, it simplifies to 5 over 6. All right, let's talk about let's start talking about these exponents. Now remember, 5 to the 7th power is 5 times 5 times 5, 7 times. There's 4, 5, 6, 7 5s. In my denominator, that can be represented by 5 times 5 times 5 times 5. And just like with our last problem, when I have something in common, a factor on top can cancel out the same factor on bottom. Kind of like they're going at war. So 5 cancels with 5, the next 5 cancels with the next 5 in the denominator, and so on and so forth, until all the 5s are either gone in the numerator or the denominator, depending on where there's more. And I'm left with, well, how many 5s am I left with? 3. So I'm left with 5 to the 3rd power over 1. Because when there's nothing left, there's an imaginary 1 there, which simplifies to 5 to the 3rd power. And I am done. So let's try that again. 7 to the 5th power. So 7 times 7 times 7 times 7 times 7. That's 5 7s. There's no exponent in the denominator. If there's not, there's an imaginary 1. I only have 1 7 in my denominator. The 1 at the top cancels out 1 at the bottom, and I'm left with 7 to the 4th power over 1, which simplifies to 7 to the 4th power, which is my answer. Now hopefully you're starting to notice a pattern with my exponents that I may not necessarily have to write this out every time, and we're going to make a conclusion in just a second. So if I have y to the 7th power, okay, 7 y's. 3, 4, 5, 6, 7. 3 y's on bottom, 1, 2, 3, and I can cancel 1, 2, 3, and I have 4 y's left. So y to the 4th power over 1, which simplifies to y to the 4th power. Hopefully you're starting to notice that as I'm canceling out them on top and bottom, I'm subtracting the number of y's I have. Okay, 7 minus 3 gives me 4. So my exponent rule states if you have the same bases on top and bottom of your fraction, you can subtract to find the remaining amount. Because notice I'm just, by canceling them out, I'm subtracting them out and I'm finding the remaining. So let's look at a little bit harder of an example. So 16v cubed over 72v to the 5th power. Now I'm going to take care of the numbers first. Remember that 16 over 72, I can simplify using my calculator. So 16 over 72, and they both have a factor of 8, so I'm pretty sure yep, so they both have a factor of 8, and so it should simplify to 2 over 9. So 2 over 9, so 16 split into 2 times 8, and 72 simplified to 8 times 9, and my common factors of 8 canceled each other out. So 2 over 9, or we can use our handy dandy calculator. 3 v's on the top, 5 v's on the bottom, 1, 1, 2, 2, 3, 3. And you'll notice I have, this time, instead of my variable being left on top, I have a 2 on top. That's the only thing that's left. Everything else canceled out. I have a 9, and how many v's in the denominator? V to the 3rd power. So notice this time my bigger exponent was in the denominator, and that is where my variable ended up. So I can subtract, and I did not do a good job of counting. I apologize for that. I put 6 v's in the denominator. Hopefully you noticed that. So I only have 2 v's left over. I can use my subtraction rule. 5 minus 3 is 2, but be careful where you put your variable. If you use that subtraction rule, there's more v's in the bottom, so those leftover v's need to stay in the denominator. So let's look at a different example. So simplify this following expression. Well, I don't have any numbers this time to worry about, but I do have a couple different variables. I'm going to write it out again just to make sure I've recognizing what's going on with a multiple variable problem. 1, 2, 3, 4, 5, 6. Make sure I count right this time. Now I'm going to make a prediction before I solve this problem. I see that there's more x's in the top, so I think I'm going to have x variables left over in the top, and I have more y's in the denominator. 6 is bigger than 2 in the denominator. I'm going to try my subtraction rule. 5 minus 3 is 2. So since the bigger amount is in the numerator, I'm going to write the x. 5 minus 3 is 2, so there should be 2 left over. There's more y's in the denominator, and 6 minus 2 is 4. And so I'm going to see if my prediction is correct. So canceling out 1, 2, 3. How many x's do I have left over? 2, and they're in the numerator. Canceling out y's, 1, 2. How many are left over? There's 4 of them in the denominator. All right, last example. So 45 over 5 simplifies to, now you can use your calculator again, or 45 splits into 9 and 5. 5 splits into 5 and 1, or just 5. My common factors of 5 cancel out, and I'm left with 9 over 1. u squared and u cubed. Remember, we're looking at the same variables. I notice that the bigger amount of u's is in the denominator. There's 3. So, and there's 2 on top. So I'm going to use my subtraction rule. 3 minus 2, if I wrote it all out, I would have a u to the first power left over. I'd have 1 u left over. And if I look at my v's, now how many are there? If there's not written on there, there's a 1. So v's, there's still more v's in the denominator as well. And when I subtract, 3 minus 1 is 2. Again, you can write these all out if you'd like to and cross them out until you start getting the hang of it and recognizing these patterns. One thing I do want to point out is if you type this into your calculator, into Alex, as you submit your assignment, it may suggest that you simplify. So 9 is as simplified as I can make my numerator. When I have this 1 out here, it's technically an imaginary 1, and my exponent of 1 is imaginary. So I could simplify this to u v squared, and that would be my most simplified answer. All right, if you have any questions, please reach out, and have a great day.